So again the question, and if you have done everything correctly, you should have found these answers. If not, please go back within the video and see what you did wrong, and otherwise please continue. So let's move on. So we now have this model of demand, supply in place. We've already looked at what happens if we move around the demand functions, the supply functions, if exogenous things, as we call it, change. And what we would like to do next is look at, well, we have a market equilibrium, but now suppose that demand changes or supply changes, that how will that affect the market outcome? How will that affect the price and the quantity in equilibrium? Okay, and if you think about that in your head, then you will already notice that what exactly will happen will depend on how exactly these demand and supply functions are sloped, right? And in fact, there are sort of two important parameters to determine how a shift in demand or supply affects the market equilibrium. First, of course, the size of the shift. The bigger the shift, the bigger the change will be. But second, what's also very important is the slope of the curves. If demand shifts, the slope of the supply curve determines the size of the changes to equilibrium price and quantity, and vice versa. And the size of the change is inversely related to the size of the change in quantity. Okay, this is something that you can only understand if you look at the graphs. So here's a graph. So in this example, demand has a relatively steep slope, right? So that means that if we would change supply, so if supply moves to the right, then we get a pretty big decrease in price, and we get a relatively small increase in quantity. However, what if the demand curve is relatively flat? So this one is relatively flat. And then if we do the same shift in supply, see, same shift as there, the same shift in supply then leads to a much smaller change in price, but a much bigger change in quantity. So in other words, the flatter the demand curve, the stronger the effect of a shift in supply on quantity, and the smaller the effect on price. Just rewind that to get a grip to that. And you can also do something very similar if you look at a shift in demand. Okay, so what we would like to have is we would like to have some grip on that, on how steep those slopes are, right? And what we usually use for that is elasticity. And elasticity is a concept that tells you how much things are going to change if you start playing around with price or quantity. So what is a steep curve in this context? A steep curve leads to large changes in price, small changes in quantity. Shallow curves, flat curves, it's the other way around. So what will be useful is to have a concept that describes the sensitivity of quantity of demanded or supplied, and with sensitivity I mean the sensitivity relative to price. More precisely, we're going to look at the percentage change in quantity, for example, that is caused by a percentage change in price in this case. So the price elasticity of demand will be the percentage change in quantity demanded divided by the percentage change in price. And again, you may have seen it in high school, but I will be a bit more deep, and maybe you didn't. And it's useful to review it anyway. So what is the elasticity of demand? That's simply the percentage change in quantity demanded divided by the percentage change in price. And that's, you will get lots of elasticities in what follows, and they will always look like this. The cause will always be here in the denominator, and the effect will always be up here in the numerator. So Elasticity of supply, you can do the exact same thing, right? Then you look at the percentage change in quantity supplied as caused by, so divided by a percentage change in price. So what if the price elasticity of demand is high? Then that means that a small increase in price already results in a large change in demand. And vice versa. So here's some terminology. We will say that demand is elastic if that the absolute value, these lines denote the absolute value, if the absolute value is bigger than 1. So in other words, a 1% change in price leads to a more than 1% change in quantity. Its unit elastic is that if that is exactly 1. It's inelastic if it's between 0 and 1. It's perfectly elastic if it's infinite, and it's perfectly inelastic if it's 0. So perfectly inelastic means that if I change price, quantity won't change a bit. And a lot of these things we get back to later in this course. So if we have a very small change in price, then this was my definition, right? So I look at the change. By the way, delta means change if you haven't figured it out yet. So we look at the change in quantity divided by how much we had. So this is the percentage change, and do that here for price as well. And if you play around with that thing a little bit, you can see that you can also write it like this. Okay, so the book is very fond of looking at changes, but what we will often do also in the exercises is look at very small changes, infinitesimally small changes, if you like. So if you have the change in quantity divided by the change in price, then and if you make those changes very small, and in mathematics we note it by this Dow thing here, you get Dow Q, Dow P, and that is by definition the derivative of Q. Look at the book to figure out exactly how that works if you don't understand it yet. But if we use this, if we observe that very small changes imply that this ratio is just equal to the derivative, then we can just write the elasticity like this, right? So again, this is the derivative of Q with respect to P. Q prime is simply a different way to write a derivative, and a way that you're more familiar with, most probably. Small warning, the book makes their life very hard. They play around with 1 over the slope. That doesn't really help, so better just to forget that. I will give you a few examples of how to use this guy, and then you can just forget about the 1 over slope rule, because that really doesn't add anything to understanding. It only confuses things. Okay, so here is my example. Suppose that we have this demand curve, 100 minus 2p. Question, what is the price elasticity of demand at a price of 20? Okay, one thing that's important to note here is that I ask for price elasticity of demand at a certain point, right? So at a price of 20. In high school, you may have calculated the elasticity of demand due to a price change. I'll also look at that later. But here, essentially what we're doing is that, well, if price is 20 and price changes by just a very infinitely small bit, then what would be the elasticity? And that's the concept that we'll often use. It's called arc elasticity, but I will also look at the other elasticity in a sec. So this was my equation for elasticity of demand. So just plug in the numbers. The derivative of Q with respect to P, that's just minus 2. You should have seen that already, otherwise you will get it in your mathematics class one of these days. And so that's my minus 2 here. What is P? Well, P is 20. What is Q? Well, if I plug in P is 20 here, then I get a demand of 60, right? So my P over Q, that's just 20 over 60. So if I simplify that, then my elasticity of demand at that price is minus 2/3. Okay, that was fun. I can do another one. What is the price elasticity of demand at a price of 30? Can also figure that one out. At a price of 30, again, I have to plug in this derivative. Again, that's minus 2, but now at a price of 30, my P is 30. What is my Q? Well, if I plug in Q into my demand function, if I plug in P, in my demand function, then at a price of 30, my demand will be 100 minus 2 times 30 is 40, right? So that's 40. So at the price of 30, my elasticity of demand is minus 2 multiplied by 30 over 40 gives me minus 1.5. And that's a different number, right, than what I had here. Obviously, I'll get back to that. What about the other elasticity, the elasticity at a segment? Sometimes you have to calculate that as well. And so what is the price elasticity if we look at the price increase from 20 to 30? Then you will have to look at this guy, right? So the change in quantity divided by quantity divided by the change in price divided by price. The change in quantity, let me get back to the previous slide. At the price of 20, quantity was 60. At the price of 30, quantity was 40. So in other words, price goes up by 10. As a result, demand goes down by 20. So my change in demand over here, minus 20. I have to look at the original quantity. Sorry, this is the change in quantity, right? And that's minus 20. I have to look relative to the original price, the original quantity at the price of 20, so that was 60. And the price change is 10, and the original price was 20. So if you calculate this, you also get a segment elasticity of minus 2/3. So one thing to note is that this thing changes along a horizontal demand function, right? A linear demand function. A different example here, so that was the example that I had previously with the demand for orange, a couple of slides back. Demand of oranges looked like this, and what you can do is to calculate the elasticity of demand at every single point. So here it's perfectly elastic, since if I change price a bit, then immediately nobody will want to buy oranges anymore. And at any point you can, again, using the same method as I just showed you, calculate the elasticity. And you see that if you go down the curve, the elasticity is going to be closer to 0. So demand is going to be more inelastic. So much for price elasticity of demand. One other thing that's useful is, well, if you look at the revenues of a firm, that's just price times quantity, right? How much money they make from that stuff. What if demand is inelastic? Well, then if you would change your price, then if you would say increase your price by 1%, then your demand decreases by less than 1%. So what happens to this product? This one is 1%, this one is less than 1%. That means that revenues will increase. If it's elastic, it's the other way around. And we will get back to that in chapter 9, actually. So if you look at the total revenue on the market for oranges, then at the price of 2,000, at the price of 5, this will be the price, and that will be the quantity demanded. So the total revenue will be 2,000, right? And I've plotted that here in this graph, and you can do that for other prices as well. And as you can see, this revenue peaks here at 1,200, which is exactly the point where the elasticity of demand equals 1. Because at that point, if you change price a little bit, revenue won't change, because the one goes up by 1%, the other one goes down by 1%. So then you're on top of your total revenue curve. Okay. We love elasticities. There are many more elasticities that we can think of, but they always have the same structure, if you like. So one thing we could also look at, and we will actually do that in a couple of lectures, is the income elasticity of demand. So again, the cause is here, the effect is here. So what tells the income elasticity of demand? That tells me how much does demand change if income changes. So in other words, my income elasticity of demand is my percentage change in quantity demanded divided by percentage change in income. In other words, you can also write it like this, and you can also use the derivative if you have the function. Fast forward a little bit, we'll get many more of these things later. This thing could be negative, right? We call that inferior goods. So a product that if you have more income, you're actually going to consume less of it. Examples that spring to mind, well, perhaps foodstuffs that are not really nice, inferior bread. If your income increases, you're going to buy better bread or something like that, so your demand for that stuff decreases. Scooters I've sometimes given as an example as well. If income increases, people are not going to buy scooters anymore, but rather they're going to buy cars. So if that is the case, the income elasticity of demand is negative. Income increases, demand goes down, so that is an inferior good. If it's a normal good, then it's positive. If it's a luxury good, then if your income increases by 1%, your demand increases by more than 1%, right? So that would be a luxury good. But again, we'll get back to these things in lecture 3. Here's another thing, the cross price elasticity of demand. So what do you do then? You look at how the change in price of product Y affects your demand for product X. So, for example, you look at how the price of cucumbers, Y, affect your demand for tomatoes, X. And again, you can also write it like this. We also have some words for that. So if this is negative, then what does that mean? That means that if the price of cucumbers goes up, demand for tomatoes goes down. So in other words, I like to consume them together, right? If my price for cucumbers goes down, then obviously I want to buy more tomatoes. And if I then also want to buy more cucumber, I think I'm mixing up the stuff, right? Okay, let me do that again. If the price of cucumber increases, then demand for cucumber will go down. If demand for tomatoes also goes down, so this thing is negative, then apparently you want to eat tomatoes and cucumber together. They are complements. Classic example here is cars and gasoline. If the price of gasoline increases, demand for cars is also likely to go down. So those are complements. If you have substitutes, the thing is positive. Coca-Cola, Pepsi, if the price of Coca-Cola decreases, demand for Pepsi is going to go down as well, since people are going to buy more Coca-Cola, so those things are then substitutes. And if it's zero, the goods are unrelated. Okay, so that brings us to the end of chapter 2, actually. So this chapter has introduced one of the most basic models of economics, supply and demand. What we're going to do in the remainder of this course actually is in the first 2 weeks look at demand, what underlies demand. So that's consumer theory. We want to know where this demand function comes from. After that, we're going to look at the supply function. We want to know where supply comes from. So we're going to look at the decisions of individual consumers to figure out where that demand thing comes from. And after that, we're going to figure out where the supply function comes from by looking at the individual decisions of firms. And that's actually sort of everything that we're going to do in this course. So this supply and demand model will always be at the back of our head. And we're going to dig a little bit deeper in those curves in the weeks that follow. But first, also today, we will look at chapter 3. But before we do that, here is another quiz. So again, only continue the lecture if you can answer these questions. And after that, we will see. So here demand is given by the function here. The question is, determine elasticity at a price of 50 and at a price of 75.